All right, in the ACT, they're not going to have a big section that says, hey, these are mean, median, and mode questions and give you the big hint. They're not going to say, this is a probability question. All right, they're going to ask you the question. You're going to have to be able to identify whether or not I'm using mean, median, mode, probability, proportions, greatest common factor, least common multiple, all that type of stuff. We're going to have to identify that on our own. All right, so let's take a look at this. I'm going to kind of go around the room and pick on different people to give me your answer. Let's see. Lily, what did you get for number 1 here? H, 200. And so if this is a question that you missed, I'm going to let you kind of drive, hey, I missed this one. I need to see how that's worked out. Okay, so I'm not going to go through every question and say, hey, who needs this? We're just going to go through it, and we'll stop at the ones that you need. Some of them are a little bit more obviously in need than others. Savannah, what did you get on number 2? Sure, and you need to see it as well. Yeah, this is to me, it's a classic example of, it's algebraic, but it gives me the opportunity to do what I call a test, all right? And we can do some tests. And when we do a test over an ACT question, we want to keep it as simple as we possibly can. For instance, we have n number of students. All right, so if I'm going to test this, am I going to pick a large number or a fairly small number? Fairly small number. I could do this with, but I can't make it so small. I can't do this like, let's say, with 1 student probably, right? Or wouldn't want to. But I can make it 3 students. Okay, I could keep it at 3 students because we're talking about averages, right? An average is the number of scores over how many students there are, at least in this question. All right, so let's keep it really, really simple, and let's say 3 students. Let's pick a fairly small number to work with, and maybe a number that's fairly direct. Let's say 10 points. Okay, let's say all, and let's not overcomplicate it. Let's even keep it simpler, and let's say all 3 students scored 10 on a math test. Okay? Well, we should be able to solve that pretty well and determine that what's the average there? 10 points, right? All right, that's what the average would be. But one student discovered that her score should have been Y points higher. Well, again, we don't want to overcomplicate it, right? So let's say that her score, instead of a 10, should have been an 11, right? Now, we're still going to find average the same way. We're just going to get a different average, right? What's 10 plus 10 plus 11 divided by 3? 10 and 1/3, right? Or 10.3, we could say 0.3 repeating. Okay, 10 and 1/3 would be the same thing. All right, so compared to the uncorrected average, and this is my uncorrected average, the new class average will be, okay? And notice how these all read points higher. So, well, nothing in there says 1/3 or 0.3 repeating points higher because everything's algebraic anyway. So let's go and look at C and see what these different things mean. Okay, we've got n points higher. Well, n is number of students. All right, so that doesn't make any sense to say that it's going to be number of students higher, right? Right, and y? Y is her score, her individual score higher. Well, that would just be 1 point, right? That the class average would go up by 1 whole point. Well, does it go up by 1 whole point? No. All right, so let's figure this out. Her increase was what? 1 point. How many students were there? 3. Well, is that the same as the increase? Yeah, it's the same as the increase. Now, so that would be y over n, right? Because this is equal to our change for that student, and this is equal to the number of students. So y over n is going to be my increase, right? And I've tried this with different numbers of students, and I've tried this with different scores. It still comes out this way, which means so long as I understand the test that I'm working with, I should still get the right answer. And we'll notice that n over y is in there. Well, that would mean that it's going to be 3 points higher, and we can see that that isn't true. Okay, does that help us understand that question a little bit easier? Okay, a little bit more complete. All right. Let's see. Dom, what'd you get for number 3? B. Okay. Make sure to raise your hand if you've got a question. 3 is B. Okay, number 4, Fanny. Didn't exactly understand it. That's fine. The average of 6 numbers is 4.5. If each of the numbers is increased by 4, what is the average of the 6 new numbers? The easiest way to do this, rather than say picking 6 random numbers and hoping that the average is going to come out to 4.5, is to assume what? What's the easiest way to get 4.5 as an average? Make them all 4.5, right? Okay? Do that as many times as you need to, and you divide it by 6, right? 6 numbers. If they're all 4.5, I divide them by 6, I'm going to get 4.5 as my average, right? Okay? It says each of the numbers is increased by 4. All right, so what's each number now? Increased by 4. Oh, I'm sorry, it's decreased by 4. Good call. All right, so all of those are now 0.5, okay? So what is the average of the 6 new numbers? So what's 0.5 plus 0.5 plus 0.5 plus 0.5? If I divide all that by 6, well, really, what am I getting? I know I'm going to get 0.5, all right? So I think maybe we do have a tendency, especially on ACT test day, to assume that the question is harder than it is, or to make it more difficult, okay? So keep that in mind with averages, where the average, we don't know what all 6 of those numbers are, but they tell me the average. I assume that all of those numbers can be the same number, and that's going to be the easier way to do that, okay? All right. Number 5, let's see, Marissa, I won't pick on you. Let's see, Jesus, you said you had like the first 16, or only had like the last 16 left to do. Do you have number 5 done? Okay, what did you get? You got 1. 1 is correct. You should get G on that. Any questions there? Okay, 6. Okay, 6, let's come back up to Lily. Didn't understand it. Okay, so you picked D. D is correct. It is 87. Jana's average test score after 5 tests in chemistry was exactly 86 points. And she scored, now this is where it's different than the other question, because they're telling me what those scores were. Okay, 78, 93, 84, 88 on the first 4 tests, but there's 5 tests. How many points did she score on the 5th test? Okay, so remember what average is, or remember what mean is. It's my numbers divided by how many. Okay, so we know that we are going to divide by 5. We know that our average is 86. Okay, we know that our tests are 78, 93, 84, and 88. That's 1, 2, 3, 4. But remember that there's 5 tests. So what would I put in for that 5th test? X. Okay. Now I want to solve for X. What's the easiest way to do that here? Okay, add these up. So what's 78 plus 93 plus 84 plus 88? All right, so I'm going to move that down here. 343, it's still 343 plus X divided by 5 equals 86, but even doing that, just the appearance of it, right, we might be able to see something we didn't see before. Okay. Yeah, I would move the 5 over, but how do I do that? Exactly. Because I'm dividing by 5, in order to undo that division, I'm going to multiply both sides by 5. Okay? That's going to eliminate that in the denominator, so I should get 343 plus X. What's 86 times 5? 430. Okay? Final step in finding out what that last test score is. on both sides. Subtract 343 on both sides. So x equals, got the 87. Okay? So that's kind of how we undo an average question. Okay? All right. Like I said, I know that I'm erasing this. We're kind of moving kind of as quickly as we can. But I'm going to post this to YouTube, and so that you guys can see it in class and go back through it and do some of these questions again if you need to. Number 7, Savannah. Yeah. Okay. To increase the mean of 4 numbers by 2, how much would the sum of 4 numbers have to increase? Okay. Again, this is kind of a test. Okay, we can test this. To increase the mean of 4 numbers. Okay, so what number do I know is going to go on the bottom of this division bar? 4. Okay, and really we could pick any 4 numbers. By how much would the sum of the 4 numbers have to increase? Let's see. To get it to increase by 2. All right, well, give me some numbers.
2, 4, 6, 8.
2, 4, 6, and 8. Okay? What's 2 plus 4 plus 6 plus 8? 20. And 20 divided by 4 is 5. So the average is 5. Okay? So to increase the mean of 4 numbers by 2. All right? So what would that mean I would want the average to be? I'd want the average to be 7. I need to add 2. All right? So I want my average to be 7, correct? Okay? So I need, let's see, a number over 4 that's going to equal 7. Okay, so I would multiply by 4. Okay, so I'm getting a number equals 28, right? So that new number on top needs to add up to 28. The number on top originally equaled 20, right? Now that equals 28. How much did I increase that set of numbers by? I increased it by 8. Okay? Like I said, you could use 2, 4, 6, 8. You could have used 1, 1, 1, 1. Right? Okay? So your test was fairly simple, and it came out really nicely using even numbers. Right? So that worked for us, and hopefully we understand it. Okay? All right, let's come down to least common multiples. Least common multiple and greatest common factor are 2 things that get confused really easily. Okay, least common multiple, Dom, number 1.
I wrote them all down, so it's probably G.
It is G. Okay, but are we wanting to know how to get there quicker?
I just wrote out like ones for 6.
Okay, one neon. Okay, 6. The other one's 8. Right. So you're looking for the smallest number that both will go into. So 6 goes into 6 one, but 8 won't go into it. Then you've got 6 goes into 12, but 8 won't go into that. 6 goes into 18. 18 won't go into that. 6 goes into 24. 8 will go into 24. Boom. I'm there. Right. Now. Granted, sometimes they're going to give you 3 numbers. Right. Let's look at number 2. Okay, number 2, Fanny, what'd you get here? E? Okay, so again, we're just looking, because it's a multiple choice test, that actually makes life quite a bit easier because sometimes I don't have to go looking for the answer. Sometimes I can plug answers in and see if they work. For instance, store manager instructs the maintenance staff to clean the sales room every 4th day. The office is every 6th day. Storeroom every 10th day. We want to clean all the rooms on the same day. When is that going to happen? Well, does 4 go into 10? No. All right, so I can scratch that off. That took me 2 seconds to do. All right, does 4 go into 20? All right, does 6 go into 20? No, it doesn't go in. All right, does 4 go into 30? No, okay. So that doesn't work. All right, does 4 go into 60? We're going to check, right? But the first 3 were really easy to get, leaving me with a 50-50, right, choice. All right, it goes in. Does 6 go into 60? Obviously it does. Does 10 go into 60? Obviously it does. And because we're looking for the first time, now 240 isn't wrong, but because we're looking for the very first. Now, this note that they give you, cleaning 4th day, means 1 day, skip 3 days, 1 day. So I took that note as like something that I would have to do. And I ended up like drawing a whole chart with where things landed at. And I ended up doing a lot more work to solve the question than what the question actually needed me to do. So what could take, 30 seconds? If you overanalyze it, could take you 5 minutes. Okay? All right. Let's see. Number 3, Jesus. What's that? You got H. H is correct. All right, move on. Number 4, Lily. C is correct. Okay, number 5. Number 5, Savannah. B is correct. Number 6, Dom. Number 6. B, no.
135. Is it that one?
Should be 6. So we got A over 30 plus B over 1. Okay. All right. So they're going to mix common denominator questions with least common multiple because they accomplish the same task. Okay. So look at this question for a second. This says A over B plus B over 105 equals 7A plus 2B over X. Essentially what we want to do with this is we can simplify the left-hand side by getting a common denominator. What number will both 30 and 105 go into? Well, should be 210, right? If I just double 105, all right? So what I would get is I would have to multiply this guy by 7 over 7, right, in order to get that, right? And I would have to multiply that guy by 2 over 2. So that's going to give me 7A plus 2B over what? 210. All right? So over here, they tell me 7A plus 2B over X. Well, now I can look at it and see that the numerators are the same. It's just the denominators are different, but it does say that they equal each other. So what does X equal? 210. It has to, right? Because the denominators are the same and the fractions are equal. Okay? All right, number 7. What time do we get out of here? I have no idea either. When the bell rings. Well, what I'd like to do is time it well enough that I can give you the answers to the rest of them before we run out of time. Number 7, Fanny. 60 is correct. Greatest common factor, number 1, Jesus. What's that? Didn't know how to do this. Greatest common factor of the monomials, 16z, 28z cubed. All right, so we're looking at the largest thing that will go into both. All right, this is kind of the opposite of least common multiple. Multiples, we're taking that number and we're trying to see where they will fit in. Now we're trying to fit things into this. Will 28z cubed go into 16z? No. All right, will z squared go into 16z? No. Will 16z go into 16z? Yeah, okay. But will 16z go evenly into 28z cubed? No. Will 12z go into 16z? No. Will 4z go into 16z? Yeah, 4 times. Will 4z go into 28z cubed? Yeah. And what does that come out to? Is that, yeah, is it 7 times? So it should be, what, 7z squared, right? If I multiplied it by 7z squared, 4z would go in. Does that kind of answer where you're hoping to get with that, with the greatest common factor questions, is what will go into what evenly? All right, number 2, Lily. B. Okay, our answer should be C. If C is a positive integer that divides 75 and 90, but divides neither 18 or 10, what would you get when you add the digits in C? All right, so we're going to go through this. Again, it's easier to use the answers that they give me than to try to come up with an answer. Will 1 go into 75 and 90? Will it go into 18 and 10? All right, so we need something that won't go into 18 or 10, so that counts 1 out. Will 5 go into 75 and 90? Will it go into 18 or 10? Yeah, it'll go into 10, okay? Let's keep going here. Let's see, will 6, trying to make sure I get the right thing here, will 6 go into 75 and 90? Actually, hold on. I think I'm going about this the wrong way. We're looking for a number that will go into 75 and 90, but not 18 or 10. So it's not necessarily one of these numbers, okay? To kind of backtrack my statement. A number that would go into 75 and 90, just to kind of shortcut through this because I kind of killed some time, would be 15, right? 15 would go into 75 and 90, but won't go into 18 or 10, right? And so what they're saying is that if C equals 15, what happens when I add the digits in 15? I get 6. 1 plus 5 equals 6. That's how I get 6. Okay? All right, so that's a little tricky. They're not giving you a set of numbers that time. All right. Probability. Probability. Okay, let's come on up here. Let's see, where did I leave off with? Oh, that was Jesus back there. Let's see, probability. Jesus, did you understand the probability questions? Did you get any of these done? Yeah. Okay, what did you get for number 1?
I got it.
5/12. Okay, 5/12 is correct. Okay, number 2, Lily. Didn't get it. Okay. Let's kind of scroll up here. Of the 50 people, okay, so let's start off with this. Probability is number desired over number total. So if we start off with that, we'll understand. Of the 50 people in a music store, 35 of them own a cassette tape player. If one of those 50 people is randomly selected to win a cassette tape, what's the probability that the person chosen will already own a cassette player? So what's the desired number of those people? How many of them own a cassette player? 35. Okay, how many total people are there? 50. Okay, so if I reduce that fraction down, what do I get? $70, which would be 0.7, right? Okay. All right, number 3, Savannah. Didn't know how to do this one. If the probability that it will rain tomorrow is 0.7, what is the probability that it will not rain tomorrow? Well, let's consider this to be 70%, right? So there's a 70% chance that it will rain tomorrow. What's the percent chance that it won't rain tomorrow? Right, because we only have a total of 30%. Can I change that to a decimal? 0.3. So if there's 7/10 of a chance that it's going to rain, there's 3/10 of a chance that it won't. Okay? So 0.3, 3/10. Okay, does that help you out? All right. For this one gets people. Let's see how Dom did. Dom, number 4, how'd you do? What'd you say? You got E? 1 over 99. Okay, remember, probability is number desired over number total. So we've got 100 marbles. And we win if on my marble it starts with the same tens digit, right? Okay, so we draw an 87. All right, so let's count how many marbles would work for me, right? 81, okay? 81, 82, 83, 84, 85, 86, 88, because we can't include 87, 89, right? I have 9 marbles that if I get one of those 9 marbles, right, it'll work for me, right? So, but how many total marbles are left? After I pulled out the 87, I'm going in and I'm picking up 99. 9 over 99 will reduce to 1 over 11. Okay, so we've got a 1 in 11 chance of getting a marble that will win the prize. Okay? Okay. Fanny, how do you do with number 5? Got D, 5 over 26 is correct. Right? The big deal with number 5 is recognizing that there are 2 E's and 2 C's. Right? So I only want 1 E. I only want 1 C. Okay? So I only have 5 unique letters within the word Rebecca. There are 26 total letters, so that's how I get 5 over 26. Okay? 6. Let's see, Jesus. 3/4 is correct. Okay? Anybody need that? No. Proportions. Let's move on to proportions. All right, number 1, Lily. You got what? D. D is correct. Okay. Number 2, Savannah. Got F. F. Nope, it's not F. Let's take a look here. Okay. A road map is drawn to scale so that 1.5 inches represents 90 miles. That's my scale. Okay. So we're going to put inches over miles. Right? How many miles does 1.6 inches represent? On the proportional side, on the other side, where do I put that 1.6? Top or bottom? Top, right? 1.6 goes on top, because if we're going to go inches over miles, then we're going to go inches over miles. Let's put X in for miles. Cross, multiply, and divide. What's 1.6 times 90 divided by 1.5? 96. 96. All right. Yes. It's probably going to take you more time to do that than is necessary. So I wouldn't, it's not a conversion question. So you're going to take more time trying to convert than you need to. Because in a proportion, so long as I keep, they don't have to be in the same units, so long as I keep both sides the same. For instance, I could have done 1.5 over 1.6, so long as I did 90 over X, right? Because I'm keeping the 1.5 in relation to itself across this way, right? And I'm still going to end up taking 1.6 times 90 divided by 1.5. It's not going to change it, right? I'm still going to end up solving for the miles. All right, number 3, Dom.
D.
D is correct. D is correct. Number 4, Fanny. You got F? F is correct. Okay? Yeah. Let's see. So again, proportions. Actually, I don't even know if we don't even really need a proportion for this. We can do this a little bit easier. It says an object on the moon is 16% of what it would weigh on Earth. If Tom weighs 150 pounds, how much does he weigh? Now, granted, that says points, so a little bit of a typo there. How much would he weigh on the moon? So we're just looking for 16% of his weight. So let's convert 16% to a decimal, multiply it by 150, right? 16% of his weight is 24 pounds. Okay? All right, 5. Let's see, who'd I leave off with? Okay, so Jesus, number 5. 2/5 is correct. Okay, number 6. Lily? K is correct. Number 7, Savannah. G is incorrect. All right, so again, scale. Let's work on a scale here. Now, so I give you a whole bunch of setup information. I'm going to skip past some of that. If I have skis that are 240 centimeters long, they work for a guy that's 200 centimeters tall. Okay, so let's do skis over height. Okay, which means when I get over here, if I find a skier that is so tall, I need to make sure that I put his height in relation to height. So we're going to do skis over height. I've got an unknown length of skis. So 150 times 240 divided by 200. Okay, 180 is correct. So we should get H. Okay. My hope is that, I know it seems kind of silly to go back over a bunch of pre-algebra questions, but do you see how many pre-algebra level questions that we do get wrong, right? So if you keep in mind how many you got wrong, and if just by doing this you would have gotten some of those questions right, how that would have increased your practice ACT score, right? Some of you probably already would have hit the 32 if you weren't already at there or above it. All right, number 8, let's see, is this is Dom, right? Okay, what'd you get here? A. Okay, so this is a way easier question than they make it out to be. All right, what they're asking is that right there. What is the ratio of FD to AD? That's all the question is. So let's think about these things. I'm going to make that a little bit bigger. All right. Is FD 1/3 of AD in length? No, it's over half, right? So we know it's greater than 1/3. In fact, here we can see on B that it's not going to be B either, right? Right? Radical 3, I think, is 1.7, right? So that's less than 1/2. We know it's not less than half of AD. We also know it's not the same as AD, right? So, and if I look at it, could we reasonably see that FG is 2/3 of AD? Yeah, that makes reasonable sense. They give you a ton of information. You know what all that information does? It does not help you solve the question, and it wastes a bunch of your time trying to make sense out of it. Okay? So hopefully that will save your life. Okay, number 9. Here's what I want to do with the remaining time that I've got is I'm going to tell you what the answers are. And if we've got time before the bell rings, we'll go back and answer as many of these questions as we can. Number 9 is 5 3/5. Number 10 is 8. Number 11 is 10. Number 12 is 550. Number 13 is 6. Number 14 is 6. Number 15 is 3/2. Number 16 is 7m over 2. Number 17 is 150. Number 18 is 135 degrees. Number 19 is $196. Number 20 is 12.5. Number 21 is 12. Okay, so let's go back. Let's see, question number 9. Did anybody need to see question number 9 worked out?
I didn't remember what the answer was.
Let me go back to it. It was 5 3/5. Yes or no?
What's that as a decimal?
Your guess is as good as. So you were. My battery's free. What? Sure. No.